Hello world and welcome. Today we will talk about CNNs, and today we are going to predict the handwritten digits. My name is Harris and let's get started. So for more tutorials or content, hit the subscribe button or leave a like or comment there. What are basically the pros of CNN? You can take unstructured data such as image classification, speech recognition, natural language processing, and just take it and analyze all this data as well. You can apply a feature learning because all the filters will learn automatically without mentioning it explicitly, and the spatial feature referred to the arrangement of pixels and relationship between them in an image. So we have here basically two types of images. We have here on the top the black and white image here, what we will also use today. And of course a color image with these three colors here. And today we'll just have this black and white digits to predict all of this information. What are basically steps in CNN? We are taking first of all the convolutional layer. Afterwards we are applying the max pooling. Then we flatten everything because we want to have a fully connection to the new neural net to have a prediction of this data. That's where we are taking all these layers here together, represented by these feature maps itself. On the very left you have the input, so it's 28 times 28 matrix of handwritten digits. Here in this case a 2, so you are taking convolution layer. Afterwards you have max pooling, and afterwards you are taking at the very last step the flattening and fully connected neural net to predict whether it's a 2 or other digit. So how does it look like in the Python code here? So we're first of all taking the libraries that we need in this case. We have here, we are loading the MNIS dataset and separating it in the X and Y data. Then we are printing the shape here. It's 28 times 28 matrix. And then we show the very first training data set is a 5. So this is the X data, so it's really the information of the matrix itself. And here you have the Y. It's showing the label itself, so it's a 5. So it's not just information of the matrix, it's just a label which represents the real number. Afterwards we are reshaping everything, then we are encoding it to fit it for the model. And then here the magic comes when we are taking first of all the first convolution layer. You can also, for example, have a second convolution layer. Then we are applying the max pooling 2D because it's only a 2D picture here. Then you can also insert some dropouts to maybe generalize your model more. And afterwards you flat everything that you can fit it in the neural net. And the last of it is the dense, or the dense layer to predict the data itself. We are fitting everything here, we're training the model. We have the ADAM optimizer here, and afterwards we are showing the accuracy. We only have 2 epochs here. You can also insert more epochs to make your model even more accurate. But you can see after pretty lowest type of accuracy that after 2 epochs you have a really good accuracy here. In this case more than 96%. And if you see the plot of the loss, you can also see over only 2 epochs the loss is pretty small. So you can imagine if you will adjust 10 epochs, you will really have a really good example of a good model. Then we predict all the data afterwards, showing here the information of the X data here, or of the prediction. Then we can see here the actual and the prediction data. So we only took the very first 4 digits, 7 to 1 and 0, and compare it to the prediction. It's a really pretty good prediction. Everything is right. So plotting it with the imshow function, you can see here 7 to 1 and 0. This the output, so prediction was really good. So thanks a lot. Thanks for watching. For more content, hit the subscribe button or leave a like, a comment there. I'll be really happy about it. Thanks a lot and see you soon.